Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we'll learn about the selection methods for motion control cards. Our lesson will cover the following 4 main topics. Through this lesson, you should be able to understand the basic steps and critical considerations for selecting a motion control card, and how to independently choose the right card based on specific application scenarios. First, let's understand the importance of choosing the right motion control card. Incorrect selection can lead to reduced system performance, insufficient stability, and increased maintenance costs. Therefore, proper selection is the foundation for ensuring system stability and efficiency. Let's begin with the first part of today's lesson, understanding motion control cards. Before selecting, we need a basic understanding of what a motion control card is. A motion control card is a hardware device that receives commands from a host computer and converts them into signals that the motor can execute. It usually includes hardware interfaces, control algorithms, communication protocols, and other essential elements, which will aid us in making an informed selection. Next, let's learn about clarifying application scenarios and requirements. The first step in selecting a control card is to clarify the application scenario and requirements. We need to consider the following aspects. 1. Controlled object. Identify the type of motor to be controlled, such as a stepper motor or servo motor. Different motors have different requirements for the control card. 2. Control precision. Determine the required control accuracy based on the application scenario, as precision machining may demand submicron level positioning. 3. Control mode. Define the required control mode, such as position control, speed control, or torque control, with some applications requiring the flexibility to switch between modes. 4. Communication protocol. Specify the communication protocol with the host or other devices, like RS-232, RS-485, or Ethernet. 5. Environmental requirements. Consider the operating environment of the control card, such as temperature, humidity, and electromagnetic interference. 6. System architecture. Understand the entire automation system's architecture, including the relationships and connections between components like the host, controller, and motor. 3. Key factors in selection. Once we have clarified the application scenario and requirements, we must consider the following factors to further narrow the selection. 1. Hardware interface. Ensure compatibility between the control card and external devices such as motor drivers and sensors. Also, consider whether additional expansion interfaces or modules are needed. 2. Control algorithm. Assess whether the control card's algorithms meet application needs, including high-precision interpolation or anti-vibration capabilities. Also, consider the algorithm's flexibility and customization options. 3. Communication performance. Check the control card's communication performance, including data transmission speed and stability. Ensure real-time communication with the host and avoid delays or data loss. 4. Scalability. Consider whether the control card supports expanding features, such as adding control axes or input-output points. This will help to accommodate future system upgrades. 5. Cost-effectiveness. While meeting performance requirements, consider the control card's cost. Choose the most cost-effective model to reduce system setup and maintenance expenses. 6. Technical support and after-sales service. Choose a supplier with strong technical support and after-sales service to ensure timely technical assistance and maintenance. 4. Practical selection steps. Let's look at the steps to follow when selecting a motion control card. 1. Market research. Gather information on available motion control cards, including model, performance specifications, and price. Understand each product's strengths, weaknesses, and market share. 2. Requirement analysis. Based on your scenario and requirements, filter and compare the gathered information. Identify products that meet your needs. 3. Performance testing. If possible, conduct performance tests on the shortlisted products. Tests can include lab tests, field tests, or simulation tests. Focus on parameters like control accuracy, communication performance, and stability. 4. Supplier evaluation. Evaluate the suppliers of shortlisted products. Consider their technical expertise, production capacity, and after-sales service. Choose suppliers with a strong reputation and reliable technical support. 5. Final decision. Considering all the above factors, select the motion control card that best meets your needs. Through today's lesson, we've learned about the selection methods for motion control cards, covering aspects like defining application scenarios and requirements, considering key selection factors, and practical selection steps. I hope you can apply this knowledge to your future work, correctly select motion control cards, and ensure the stable and efficient operation of your systems. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.